okay for you? Yeah. Okay. It's true.
So, good morning, bon matin, something like that. I will be speaking on the future of blockchain oracles and what decentralization means in an oracle network. You may probably have heard of the oracle problem, but the first thing you need to know about this problem is that it's not formalized at all. So when someone is claiming that they are solving the oracle problem, what that does really mean? What's even an oracle at all? So an oracle is some entity that gives you knowledge, that gives you access to information that you cannot have access directly. So it's a kind of a middleware relay for information that you cannot avoid. You simply need it. Oracles are a thing in Ethereum and in the smart contract world because smart contracts are completely isolated from the rest of the internet, from the rest of the world, and that's for a good reason, because at the end of the day, a smart contract needs to be executed in a totally deterministic way, because it's a program that will be executed across multiple instances of the EVM, so it needs to have always the same result as long as it operates on the same data. So if you connect a deterministic program to non-deterministic sources, you are contaminating it with non-determinism, and you will not be able to resolve, to find consensus on the result of the contract. So in some way, we can say that an oracle is some kind of middleware that abstracts away the non-determinism from these contracts, that it says how those uncertainties need to be resolved. So the very moment that you take your smart contract and you connect it to a data source from outside, you're breaking the very most important property of smart contracts, which is tamper resistance. Decentralization and trustlessness are only the way to achieve tamper resistance, but at the end of the day, what we expect from smart contracts is tamper resistant. We want them not to be manipulable by anyone, not to be censored by anyone either. And for any system, its security equals that of the most non-secure element in it. So we need oracles, we need those entities bringing data into contracts to be as secure, as decentralized, as trustless as the smart contract consuming them are. So what I will be talking about is the research on, and all the development and all the design goals that we at WinNet Foundation have taken into account when creating a truly decentralized Oracle contract, Oracle network, which is WinNet. The first design goal is data integrity, because the tamper resistance, when we are looking at oracles, boils down to data integrity. So preserving, ensuring that the data that is sent to the smart contracts is exactly the same that is presented by the data sources, by APIs, for example. So the first way that we can achieve that is by doing some kind of crowd witnessing. So taking multiple nodes from a network and making them go to a certain API or to a certain website and download the content and report that to the network. That's the way to achieve that is by having a big pool of nodes in the network and randomly selecting a subset, a small amount of nodes from that pool that will have no conflict of interest and that will report the value coming from the API, from any data source, and this is chosen using a cryptographic sortition algorithm that guarantees that it's not predictable. So this creates incentives in a similar way to Schelling point schemes or to Vitalik Buterin's Schelling coin, because those nodes will be only rewarded if the data they bring into the smart contracts is in consensus with that with the data that the other nodes is reporting. So for that to happen, we need a commitment and reveal scheme, which means that the nodes create secret commitments to the data points so that they cannot deny them afterwards, they cannot change afterwards, and then they reveal the actual values they got from the data sources. That prevents freeloading, that prevents one nodes copying each other. The other thing that we need is aggregation or multi-source fact-checking, which means that at the end of the day, if what we are saying is that we cannot rely on a single entity to provide information into our contract, we cannot either rely on a single data source, because it's pretty evident that in some high-value Ethereum contracts, the data sources that we are querying could have high incentives to manipulate the data so that they tamper with the result of the contract. So we need to query multiple data sources and aggregate all the data in a deterministic way on-chain. And one other thing that we need is node indistinguishably, which means that the data sources should not be able to distinguish nodes in this Oracle network from their regular consumers, from their regular users, because otherwise it would be really, really easy for them to target them with fake data in order to tamper with the contract without any negative impact on their public image or on their reputation, let's say. So the second design goal out of 3 is fairness. Fairness means that there's a very, very low barrier to entry. So you, as a developer or as a techie, should be able to create your own node, to put a computer to resolve these data requests for bringing data into smart contracts without big barriers to entry. This is not something deliberately decided. This is very, very important, because the lower the barriers to entry, the more the bigger the variety of node operators and nodes that there will be in the network, which means that it's much less likely that they will collude to tamper with a contract, okay? So the low barriers to entry come from having no requirement of minimum reputation, because there's a reputation system. There needs to be a reputation system in the network to ensure that we assign these data request tasks to the nodes that have behaved and abided by the protocol more over time, and the ones that have been reliable over time. But it's important that even if you don't have any reputation, you still have a chance to participate in the protocol. Also, that no stake is demanded to participate, and that the requirements regarding hardware are very low. Then the reputation system means that the power of each node in the network, its influence, and its potential income from resolving these tasks is proportional to their past performance. The reputation score, the reputation points, flows from the outliers, from the cheaters, from the nodes that are not behaving, to the nodes that are reporting data in consensus with the other nodes that are selected for that mission. And there needs to be some kind of progressive demurrage, which means that only because you have reputation points, you lose reputation points. And the more reputation points you have, the more quickly you need to lose them in order to make the most important nodes in the network accountable, to make them liable in case they corrupt. Okay, so it's a kind of this phrase: with great power comes great responsibility. And the third, very, very important design goal is parametrization. So, for example, we can parameterize what's the size of the committee, how many nodes will be retrieving the data, the quality requirement, if we want the data request to be retried if we don't achieve consensus, what are the rewards, the fees, maybe optional collaterals, what's the retrieval, the aggregation, and consensus function, so how data will be retrieved from the data sources, how it will be aggregated, how it will be transformed, normalized, so that from multiple data sources, we end up having a single data point. And this is, in our case, we do this through Radon, which is a DSL, a domain-specific language that we have defined for deterministic transformation and aggregation of data. It's a kind of functional language that resolves all the indeterminations in a very expressive way. And at the end of the day, how it works, it's something like that. You have your Ethereum contract, and from your Ethereum contract, you make a call to a contract in Ethereum that is the WinNet bridge interface that translate that call into a WinNet data request. A WinNet data request is a Radon file that describes how data will be retrieved, aggregated, and delivered. So this data request gets assigned to a randomly sampled nodes committee from all the nodes in the network. How many nodes will be used is decided by the data requester, so by the creator of the Ethereum contract. And as soon as those nodes have discovered their eligibility for resolving that particular data request, they go to the APIs that, or the data sources that are specified in the data request. So for example, in this case, two different weather APIs. They aggregate the results coming from the APIs, and they secretly send these anonymized commitments, which are published along a proof of their eligibility that is constructed using a verifiable random function. And after there are enough commitments, they can reveal which is the value that they got from the APIs and constructed and came with through applying the Radon functions that were specified in the data request itself. So they reveal the values, and at the point, any node in the network can apply the consensus function defined in the data request itself to tell which are the outliers, which ones will not be rewarded, and which ones voted with a consensus. And this consensus don't need to be a mode or an average. It can be filtering out those outliers that simply are twice away from the average as the standard deviation, and then get me the average mean, and then convert that into an integer or a float or whatever you want. And then simply we get back the final data point into the Ethereum contract. This is something that is already working on our testnet that we released last January at Arcon. What we presented was exactly this use case of retrieving data from the weather data from 2 different APIs, and it works thanks to WetNet Rust, which is our first implementation of the protocol using the Rust programming language. And we also have this desktop client, Sheikah, which is in one hand is the wallet for the token that is native to the WetNet blockchain, and in the other hand is also an integrated development environment for the data requests for creating these Radon scripts. And our next steps is publishing the WetNet Ethereum bridge contracts that will allow Ethereum contracts to interact with the WetNet decentralized Oracle network, because nowadays you can only create this data request inside WetNet and have their results delivered inside WetNet, but this is our next step to connect it to Ethereum. And also the library, the Solidity library that will abstract away Radon from Ethereum contracts, so that Ethereum contract developers can request information through WetNet without having to learn Radon, even if it's super cool. But that's something that we don't want them. We don't want to force them to learn one more language. And we will be releasing mainnet for our network by the end of the year. We're currently hiring Solidity developers, React developers, Rust developers, and any contribution on GitHub is welcome. And I hope you enjoyed my presentation. And if you have any questions, you will need to request the microphone. Thank you.
Hello? Okay. Thomas from Oracle Eyes here. So thank you for the presentation. Very interesting. I think you have explained quite a bit what kind of guarantees are given within the WetNet network. Can you maybe say something about the ways like the Ethereum context can understand the legitimacy of data that it gets from the WetNet context? Like once the data makes it on the blockchain, how could like an Ethereum smart contract verify that it's really coming from WetNet and that the guarantees promised by WetNet are like preserved over time?
Yeah, thank you. So how this works in our first implementation is that the Ethereum contracts make calls to the WBI, the WetNet Bridge Interface, which is a very kind of dummy contract that holds the rewards, the payment that the Ethereum contracts make in ETH or any ERC20 token, and holds the rewards inside. And then the WetNet nodes observe the state of that contract, so they see the calls that are going to the contract. They replicate that calls in WetNet. They translate that into data request, into Radon. And then when the data request is resolved, what happens is that some of the nodes are randomly selected to report that data back to that WBI, to the WetNet Bridge Interface, to the contract inside Ethereum. And these what happens in there is that they present a proof that proves that the final data belongs to the WEDNet blockchain. So they prove that that's the result for that particular data request, and that was anchored into the WEDNet blockchain. And the way that the Ethereum contract verifies that is because it has all the block headers from the WEDNet blockchain inside its state. So it's a scheme kind of similar to BTC Relay, in which you can verify Bitcoin transactions from Ethereum. So it kind of works in a similar way. And finally, what happens is that you, as an Ethereum contract developer, will have a method in your contract that only can be called by the WBI. So that's like your callback for the result, and that's where the final data will go to. Yeah. Please do.
Sorry, very quickly. I guess what this implies is that there will be a subsidized cost by someone for maintaining this state on the blockchain. That's very interesting. Since your subtitle is like what decentralization really means, which to me is an open question mark for the entire community, and we don't know yet. A second question that I wanted to ask you, and I didn't find addressed here, is like, what do you think is the cost of decentralization in the context of an oracle?
Yeah, the entire point of the third design goal, which is parameterization, is exactly that. We envision an Oracle network as something that works in a very low level. It's a very low-level piece of infrastructure inside the stack. So what that means is that we cannot foresee what are the use cases that will be built on smart contracts once they get connected to the internet and to the outside world. So those use cases will have multiple trade-offs regarding security, redundancy, latency, a lot of criteria that we cannot predict. So our point is that we need to make our design generic enough and parameterizable enough for each user to decide what are their trade-offs and what they need. So that's why you should be able to choose every particular parameter and buy yourself the degree of decentralization, of trustlessness, and tamper resistance that you need for your contract. For example, if a contract is supposed to secure a very big value, it's desirable that the nodes, the WEDNet nodes resolving that data request will need to put some kind of collateral for them to be more liable in case they try to tamper with the result. But that's only a parameter. Maybe what you want to do is requesting the data through more nodes or using more sources. It's totally up to the data requesters to find what are the sensible thing to do for their use case, but that could be a nightmare at the end of the day. So what we expect is for the community to find what are the sweet points and come with templates for things that kind of work for the 99% of the cases. Okay, thank you very much.